Hello, everyone. A very good morning, afternoon, and good evening to all my folks joining from different time zones across the globe. I am Aisha Darga, and I'm super excited to be your guide on a journey that I like to call the Gateway to Tomorrow. So, before I dive right into the session, let's have a quick look at what do we have planned for the session today. To begin with, I will be taking you through a little understanding about what exactly a language model is, followed by trying to understand the difference between Gen AI and traditional AI. We'll then look at an introduction to the watsonx platform, followed by which we will take a deep dive into one of the components, that is watsonx.ai, for this session today. And while I'm giving you an insight on watsonx.ai, I will be taking you through the entire prompt lab, a detailed walkthrough of the prompt lab and the tuning studio. We will then look at what are the strategies you need to follow or need to have in mind while you choose a model with your use cases. We'll then see uh, about the hype around the granite models and what exactly these granite models do, why are they so important, and what is the actual functionality of these granite models. Followed by that, we will look into some of the Gen AI use cases which have been very popular amongst the enterprise solutions nowadays. We'll then look into one of the most important or prime aspects, I should say, the Instruct Lab. This is one of the latest features that has come with Watson X. So we will try to cover a little on Instruct Lab in this session, and we'll finally take a little demo on the watsonx.ai piece. With that, let's directly dive into our session for the day. So I'm sure most of you or all of you who are on this call are already aware of the impact foundation models or LLMs have been bringing in our day-to-day lives. So let's not spend more time on understanding why we need foundation models and directly dive into the what's and the hows of foundation models. Now, with the boom of ChatGPT, the term large language model or LLM has become even more familiar amongst the crowd. So these language models are basically subset of foundation models. Now, foundation models can be trained on any type of data. It could be images, audios, videos, etc. Out of which LLMs are trained on natural language and hence they perform extremely well with NLP tasks. Now let's quickly take an example here to understand a little about the functionality or working of a language model. Now I've given a question to the language model, say, the capital of France is, and we would definitely expect the language model to respond and give the answer as Paris. Now, one misconception that most of us have here is that the language model is trying to answer your questions, whereas the LLM is merely generating the next best token. When I say so, what I mean is whatever input you give to a language model, it converts it into a set of tokens and then tries to figure out what is the next token with the highest probability that fits in and gives that as a response to you. Now, this concept of LLM trying to generate the next best token is very important and a key aspect for us to understand before we start diving into prompt engineering or even before we start designing an entire framework. This is the crux of how the language model would work. With this, let's quickly take a look at the differences between Gen AI and traditional AI. So while you look at the chart that is displayed, I will quickly take you through a couple of most important differences here. So first, foundation models are trained with unlabeled data, whereas traditional models are trained with labeled data. Now, one most important aspect to see about generative AI models here is the fact that they are not trained for one specific task and hence are easily transferable or adaptable. When I say so, I mean that a pre trained model can easily be tweaked using prompts or other methods, and it could be used for some other task. So, if you have designed a model for summarization, you could just tweak your prompt and make it used for Q&A as well. Whereas in traditional AI, this concept does not work. A model is trained for a specific task and does not transfer or does not adapt to any other task. Now, this diagram here would basically summarize what I just said. So if you look at the first block here, you can see this is about traditional AI models. You can see that I'm passing one kind of a data set to a model and it does its specific task. Similarly, we give the other kind of data set to another model and it does its task. So they're all siloed models and they do their own specific task. And hence we say that traditional AI models are not adaptable or transferable. Whereas if you take a look at the second block here, which says about foundation models, you can see that we have a huge variety of external data that we are storing in. Say, they're all of different kinds: images, audios, videos, PDFs, etc., which we are feeding into a massive foundation model. Now, this model then decides what task it is supposed to do based on the prompts that we write. So what this model does is that it looks at the prompt or the instruction that you pass to the model and decides whether it needs to summarize, whether it needs to do a Q&A format, whether it needs to do some translation, etc. And that is why we say that foundation models are easily adaptable with little to no training. So with that, now we have a little ground set about what AI is, what Gen AI is. So let's put that AI to work with watsonx. Now, what is watsonx? watsonx is IBM's AI and data platform. It has three main components: watsonx.ai, .data, and .governance. So as we mentioned in the beginning of this session, this particular session is for watsonx.ai, and in the upcoming sessions tomorrow and the following day, we will be covering on .data and .governance. But let's take a quick glimpse at what each of these components does and then dive into watsonx.ai. So, watsonx.ai is basically an enterprise studio that helps you to train, validate, tune, and deploy your AI models. It can be used both for Gen AI and traditional AI capabilities. So, this is a single platform which gives you the best of both the worlds. And this has been thought through because most of the enterprise solutions they prefer to leverage the usage of both Gen AI and traditional AI models. We next have watsonx.data, which is a fit for purpose data store built on the Open Lakehouse architecture. Here, you can scale your AI workloads for all your data anywhere. Next, we have watsonx.governance, and this is a very important aspect when we speak about AI altogether. What watsonx.governance provides you is with an end-to-end toolkit that will help you to govern your entire AI lifecycle, starting right from the AI model development. It helps you to satisfy any regulatory compliance or even manage risks that are dealt with your AI workflows. So, with this, what we are trying to say here is with watsonx, you can select and tune AI models, you can scale AI use cases faster, and you can implement AI with trust. Now, let's directly go into our watsonx.ai piece for this day. And we'll start with understanding the components that we have on the watsonx.ai platform. Okay, so here we have five most important aspects that we cover. One is the foundation model library. Now, this library consists of models that are both IBM specific and open source. We then have a prompt lab where you could go ahead and experiment with these foundation models and build your prompts for your own use cases and try to see which foundation model is the best fit for you, how you can improvise prompts, how you could get the best results. All of this prompt engineering piece can be done with the prompt lab. We then have a tuning studio where you could go ahead and tune the foundation models with some label data. We then have a data science and ML ops that helps you to build ML models automatically with model training. And finally, Instruct Lab is the latest feature that we have. With Instruct Lab, you can actually enable a rapid LLM development with an approach that helps you to tune and train models with skills and knowledge. We will dive deep into each of these aspects now. Before that, just take a look at this chart where it shows you the different foundation models that are currently present on the studio. When I'm giving you a walkthrough of the prompt lab, I will again be showing you this chart. And for those of you who want to experiment, go ahead and try to create a tech zone instance for yourself and just experiment with these models. It would be a very good exploration and a learning for all of you. So now I've spoken a lot and I've told prompt a couple of times since we began this session. So let's try to break down and understand what prompt engineering itself is. So we did see in the slide that I was just explaining that foundation models are adaptable. One way of making them adaptable is using prompt engineering. Now, what exactly is prompt engineering? It is a way of finding the best prompt for your use case. So, what you're doing here in prompt engineering is you write different kinds of prompts, try to use different foundation models, and check which is the best fit for your use case. Now, when you understand what is prompt engineering, what exactly is a prompt? Prompt is nothing but a way to communicate or instruct your model. So, what we do is a prompt basically communicates with your foundation models. So, whenever you want to pass an instruction to the foundation model saying, hey, this is the task that you're supposed to do, and this is how you need to respond. All of this goes to the foundation model through the prompt that we write. So, in simple terms, prompt is a way to communicate with the foundation model and tell it what is the task and how it is supposed to respond. With that, let's look at a couple of examples that are here. The first one is zero shot prompting. Here, my prompt or my instruction to the model is translate English to French, and I'm giving it the word that needs to be translated, that is cheese. I'm not providing any example to the model, and that is why it is called a zero shot prompt engineering. Next, we have a one shot prompt engineering where while I'm giving the instruction, I'm also giving one example to the model saying, if sea otter stands for so and so, what would cheese be? When I give one example, it is called a one-shot prompt engineering. And the next one, you can see that I've given multiple examples here. So this kind where you give more than one example is called a few shot prompting. Now giving these examples come very handy when you want your model to give a specific kind of response. So giving examples would actually help you improvise the performance of your model. So let's not go into the PPT for Prompt Lab and rather just directly jump into the actual Prompt Lab walkthrough. Uh, right now, I'm showing it to you on my own platform, but what you could do is just take this recording of this session and try to create a tech zone instance and experiment around this lab. I will be showing you how exactly you can build prompts, how exactly you can run prompts, and etc. So go ahead and try to experiment on that. And in the upcoming sessions, if you want, you could again come back and see if everything looks good for you. So with that, before going to Prompt Lab directly, let's take a look at a couple of housekeeping things that you need to do so that you're all set to begin your prompt engineering. So this is the homepage of watsonx Studio. If you scroll down here, you will see various projects created for you. Now, if you are using it for the first time, you will already have a default project created for you. If you do not see a project created for you, just go ahead and create a new project for yourself. It should be straightforward. You just need to give a name and you could create the project. What I'll do is I already have a project created for this session, so I'll just go into that. And couple of things to see here. you will see that we have an overview page which kind of gives you a history or a recording of what all you have done so far in this project. It also gives you an idea of the resources you have used so far, the number of tokens that you have exhausted so far. All of this is present here on the overview page. You then have an assets page where all the work that you do and save, like any prompt that you write and you save, you could find it here. Also, if you want to create a new prompt or create a new notebook, you could go ahead and create from this particular assets place. Then we have manage here. Now, this is the most important aspect that I want to cover. So when you go to the manage tab, go to services and integrations and make sure that you have a Watson machine learning instance associated here with your instance. If you do not have this machine learning service integrated, you will not be able to go forward with the prompt lab. It will directly give you a message that okay fine, you need to have a ML instance associated. For those of you who do not see this instance, just go ahead, click on associate service, and you will be able to find your machine learning instance. Click on that and associate. Once you do this, you're good to go ahead and start your prompt engineering aspect. One more thing to highlight here is that in case you want your prompt to be visible by somebody else or add collaborators, you could do it from the Manage tab, Access Control. You could just go ahead and add collaborators here. With this, let us go back to our home page and quickly start on the prompt lab. Okay, so here you can see that we have three forms of doing a prompt engineering piece. One is a chart way. Second, you have a structured format where the studio itself gives you a placeholder for giving the instruction, for giving the examples, for giving your test prompt. All of this is in a specific structured format. Or there is a free form way where you could just go ahead and start typing your prompt and put your examples randomly in a more ad hoc fashion. So you could use either of these ways to explore and write your prompts. For this particular session, I will stick to the structured format. So what I'll do is I will quickly take one of the sample prompts. Now, for those of you who are seeing the studio for the first time, there are multiple sample prompts that are already available on the studio. So if you have not tried using prompt engineering so far, this will be very handy and very helpful for you to understand how exactly prompts are written, what are the parameters, etc. You could use this as a reference and start and then build your own use cases. So let's quickly take one example here, say earnings call summary. Now you see that the instructions have populated and the model has been pre-selected. So let's take a look at what we are trying to tell the model. I'm telling the model, the following document is a transcript from a financial earning call. Read this document and give me a short summary or one paragraph summary for the same. And if you scroll down, you can see that the entire document or the transcript of the call has been put here. Now, this is a huge transcript, and what I'm asking the model to do is convert it into one short summary for me. Now, what you see here are model parameters. Now, this is a very important aspect when we do prompt engineering. You need to understand what these parameters do and how you can use them to get the best results out of your prompt. So the first thing that we see here is decoding methods. Now, decoding methods can be either greedy or sapling. We use greedy method when uh, we have use cases that are less creative and fact based. So what I mean to say is when you use a greedy decoding method, it always responds back with the highest probability token. So it produces n number of tokens which could be your response and then chooses the token with the highest probability and passes that as a response for you. What happens in such cases is if you have a similar kind of question asked n number of times, the response will be same for the n number of times for the question. So in use cases where you want fact based answers, this greedy method is very helpful. Whereas sapling is used when you want some creativity or some variability in the responses that you look for. For example, if you are looking for an essay generation or a mail generation, a little creativity is actually helpful for you because you do not want that every time a marketing campaign is sent out, the same text is there. It would just get boring. So we use sapling when we want more creativity in the responses that we have. We then have repetition penalty. When I am setting it to 2, I'm telling the model not to repeat the tokens present in the response. We then have stop sequences. Now, this stop sequences can either be a word, it could be a single character, it could be a punctuation mark, or it could be an enter. What I'm trying to tell the model here is, in case you witness any of these characters or character, make sure that you stop generating the response. I will show you the importance of stop sequences in one of the examples ahead, but just understand why we are using the stop sequences. And minimum and maximum tokens is pretty straightforward. So if you have a use case where you want to generate a code and you're aware that the code has n number of lines, you could just go ahead and tweak this maximum tokens to a higher number so that you get your entire result at once. And since you're experimenting with this lab, you could just go ahead, tweak and play around and figure out what is the best fit for you. With that, let us quickly go ahead and generate and see what response do we get. So you notice from this entire document, which is huge, the model has been able to pick up the most important aspects and give a very nice user-friendly one paragraph summary to the user as we asked for. With this, let us quickly take one example which uses sapling method as well. For example, marketing email generation. Okay. So now when you see sapling, you will notice that 3 other parameters have also been added here. Now, one thing that I want to show all of you is when you are experimenting on this platform here, you need to go ahead and just look into the documentation here. This is very helpful. What I am doing now is giving you a high level idea of these parameters. But for those of you who want to understand more about these parameters, go ahead in the documentation present here. You'll find prompt lab, and here um, you will find model parameters for prompting. Go ahead and read about this. This gives you a very nice idea about how setting these parameters to the right value can get you the best response. So let me quickly explain you a couple of things about sapling. One, we did say that we use sapling in cases where we want some creativity or variability in the response that we get. So temperature is the parameter that tells the model the higher the temperature, the higher the creativity that the model can have. Then we have top P and top K. Let me quickly jump to the documentation to take you through an example. Okay, now say for instance that the model has already generated so many words for you. Okay, now in the real scenario, the tokens will not be these word format. It would actually be a token. So I'm just giving you an example which will help you understand what top K and top P parameters mean. So let's quickly just understand how we can set these parameters. So what I'm assuming here is that the model has already generated, I took my dog and wants to find out what is the next best token it can append. And here is the list of tokens that it has got. Out of this, it needs to choose one token to complete this sentence. So here you can see that each of these tokens that it has generated, there is a probability score against it. So what the model does is it arranges it in the probability score manner. And when you set top k to a specific value, say I set top k to 3 from here. If I set top k to 3, what the model does is it will look at all the tokens that it has so far, and it chooses the first 3 as the prominent tokens, and from the top 3 tokens it will give one of the token as the response randomly. Because we have chosen sapling and we are wanting to have some creativity, it would go ahead and randomly choose one of the tokens from the top 3 tokens. Top 3 in case when we set top k to 3. Whatever number you set top k to, the model will go ahead and basically take the response from that particular set of tokens. We then have top P, which is very similar to top K. The only difference here is that it picks the tokens with the highest probability scores until the sum of the score reaches the threshold value or the value that you set. So if you set top P to zero point 0.6, it will go ahead and make a sum of all the probability. Once it hits the probability of whatever you have set, it will stop there. From the two that it has shortlisted, it will take one of the token and give that as a response to you. Now, this is a very high level explanation of top P and top K. I would highly recommend all of you to look at this documentation, explore different values here, and understand how the model is functioning. With that, let me quickly take a look at what we are telling the model here. We are telling the model to generate a marketing message for the company with the given characteristics. And I have put the characteristics of the company down here. Now, if I generate, you can see that the model has actually picked up from the characteristics. Say, for example, I have only given end date July 15. But if you notice here, the model has actually been able to make it more user friendly, more candid kind of a response. And it tells the user that, okay, the deadline is July 15th, so hurry. Now, this kind of a marketing message would actually attract more audience as well. So, this is how you tweak your parameters to get the best results out of your prompt. With that, let us take one more example before we move to Tuning Studio. Say questions about an article. So this is one of the examples that we will go through now. Let's see what we are trying to tell the model here. Here I'm telling the model, answer the following questions using only information from the article. If there is no good answer in the article, say I do not know. And you can see that I've given an entire article here. Now, what we are doing here is we are restricting the model to stick to the context that we provide here. Now, when I say context, this entire approach is also called as retrieval augmented generation or RAG approach. And this kind of approach comes very handy and useful when you have some enterprise use cases where you want your model to only stick to enterprise specific data. You do not want the model to go about searching on the internet and getting you some hallucinated answers. In such cases, this RAG approach comes very handy to you. What we do here is we restrict the model to find the response from the data or from the context that we provide, and we clearly mentioned saying if there is no good answer in the article, just say I do not know. This ensures that it does not hallucinate any further. Now you'll also notice that I have given two examples here. So this makes it a few short prompt engineering. Along with this, you could also notice that the decoding method is greedy and we have used stop sequence here. So let me quickly generate and see what kind of a response it gives. Okay, so the model has responded with the answer. It has basically been able to find data regarding this question within the article, and hence it has picked out that particular response for you. Now, let me quickly remove the stop sequence and generate this answer again. So what you notice here is that the model still gives you the right response, but along with that, it is also appending further information to it. So this loops us back to the point I made in the very beginning of the session where I mentioned LLMs do not answer your question, rather they are generating the next best token for you. So what you see here is that the model has understood that the way you are functioning is a question answer format. So the model is then giving you the tokens with all of that saying, okay, now that I have responded, the model has become so smart to understand that, okay, the next token that can come is a question. So it is giving you a question and the answer and again the question answer till it exhausts the number of maximum tokens that you have given here. So in such cases, stop sequences come very handy. So now if I add a stop sequence as an enter and I generate it again, you will see that all the values are not coming up now. So this is a good thing with stop sequences when you are aware of when you want the model to stop. Now there might be use cases where you're not sure where exactly do you want to stop. There might be summaries that you want to generate which might have an enter and you don't know where exactly it needs to stop. In such use cases, what you need to do is you need to improvise your prompt, write better prompts and try to give more examples to the model so that it understands what exactly you are looking for or what kind of a response you are looking for. Now, with this, I'll quickly take you through some more aspects of the studio, and if time permits, I'll show you one more prompt towards the end of the session, which will give you an idea about how to use freeform as well. So, along with all this, on the studio, you can also see that this was a no code method of generating your response. There is also a way that you could use the code if you want to, or if you have an existing code and you just want this to be run there, or you want to append this entire working of functionality in your existing code, you could just go ahead, click on this icon here and get the Node.js code or the Python code or the curl command. Just pick this code and paste it in your existing enterprise code and get it working as an API. Along with this, what I want to highlight is the foundation models that are present. So what I would recommend is when you're experimenting on this, just go ahead and choose different kinds of models. You can see that there is a wide range of models that are present here. You could choose any of them and explore on how your use case gets the best result. Things to notice here: one, there are models both from IBM and from open source present in the same platform. You can see IBM, CodeLlama, Google, you can see Hugging Face models, all of these present in the same platform. Another thing to notice here is that you have models right from as small as 3 billion parameter models to as big as a 70 billion parameter model. So there is a wide range for you to explore and work with. So go ahead and experiment on these. If you want more details about any of these models, just click on them. It will give you a model card which tells you their main functionalities, what it is supposed to do, and it also gives you idea about how it was trained, on what kind of data it was trained. So it helps you to choose the model best one for your use case. With this, one more thing that I want to show you here is the ways you can save your work. So when you want to save, you could save it either as a prompt template. What this will do is it will save the latest prompt as is, as a template for you, along with the parameters and everything that you have chosen. You could also save it as a prompt session, which will store the entire history of the changes that you have made to your prompt. Or you could store it as a notebook, which will actually generate a Jupyter notebook for you. So let me quickly show you one notebook here. So if I try to generate this notebook here, it will take some time, and if I go back to my project, I did show you in the assets, you'll be able to find all the things that you save. So you can find test notebook here. If I open this, you can see that a Jupyter notebook has been populated for us. So you see all of these cells are present here. Now, what you can do is either you can run this notebook right here on this platform, or you can pick and paste the code in any of the other interface that you would like to run it on. Let's take a quick look at how we can run it on the platform. All you need to do is click on the edit icon. It will start instantiating a runtime for you, which will take a couple of seconds. Once the runtime is up, you can directly run this entire notebook on the same platform like you would do it on your Jupyter interface. So let us wait till this instantiates the runtime. So you can see that now we have our notebook generated for us, and you can see that it gives you a way to run all of these cells right here. So if you want to actually use this notebook to change your prompts, you want to change your model, you could just go ahead, change your model and keep running these cells and use it as a Jupyter notebook to run your entire prompt engineering aspect. If you want to convert this into an API, all you need to do is pick this code from here, paste it, and try to deploy it, and you will be good to go. So this is how you can utilize notebook functionality on the watsonx Studio. With this, let us quickly move back to our slides and take a look at prompt tuning. Just give me 1 second. Okay. I hope prompt engineering aspect was clear to everybody, and I hope you are now a little comfortable with how you could use the prompt lab. If not, I do see a couple of questions come up on the chat, but in the interest of time, I'll take up those questions towards the end. So let us just try to complete this entire flow and then we'll dive into the questions. If I'm not able to answer those questions in this session, I'll reach out back to you, or in the session that we have tomorrow, we'll definitely address those questions for you. Okay, so now once we understand prompt engineering, let's look at what exactly is prompt tuning. So far we have noticed how LLMs are large reusable models that are trained on vast amounts of knowledge and are super flexible. So we did see that the same model could either give you an analysis on a legal document, or it could even write a poem for you, or it could even give you the recipe to your favorite dish. So it is a very super flexible environment here. But what if you want to improve the performance of a pre-trained LLM to address a specific task? In such cases, there is an energy efficient technique called prompt tuning. Now, this allows a company with limited data to tailor a massive model to a very narrow task, and there is no need to gather tens of thousands of labeled examples like you would actually do if you're using something called as fine tuning, where you need a ton of different examples to train and change the model weights. That does not happen here. So in prompt tuning, what we do is the best front end prompts are fed to the AI model to give it the task specific context. The prompts can either be extra words introduced by a human, or most commonly, these are AI generated numbers introduced into the model embedding layer that guides the model towards a desired prediction or a decision. Now, what we just saw in prompt engineering was we trained a model to perform a specific task with just one single prompt. We did not have to retrain the model, we did not change weights of the model, nothing. But if my task is complex and if I have to uh, have dozens of prompts, in such cases, these handcrafted prompts will be replaced by AI designated prompts called tunable soft prompts or just soft prompts. Unlike the human written or hard prompts, the AI designated soft prompts are not recognizable to human eye. Each of these prompts consists of embeddings or string of numbers that distills knowledge. In simple words, prompt tuning is basically a faster and a sustainable way to extract knowledge from large models while you keep the model frozen. So the model is not touched. We are not changing weights of the model. All we are doing is keeping a soft prompt on the layer and making it work for the domain specific use cases. Now, similar to Prompt Lab, we also have a tuning studio on the watsonx Studio where you could go ahead and perform prompt tuning. Currently, this feature is available for three models, the Flan T5, Granite, and Llama model. And it could be used for three different use cases, that is classification, generation, and summarization. Let me quickly jump back to the studio and show you what exactly I mean by tuning studio. So if you go to the home page back, you can see there is a tile for tuning studio. Just click on that, and very simple. All you need to do is give a name, create a tune. You will see that the studio itself will take you through each of the steps very efficiently. So what it is asking here, first thing, which is the foundation model that you want to tune? So let's select. As I mentioned earlier, we are now having three models that you can prompt tune, either Granite, Flan, or Llama. So let me just choose Granite. You'll see that the model card appears just for you to ensure that you're checking the correct one and select. Now, once I select the model, it will ask me how do you want to initialize your prompt, whether you want a random prompt to be given or do you want to give instructions directly. So for this particular session, let's just go ahead with random. Once I choose random, it will ask what task are you looking to do, whether it is classification, generation, or summarization. So whatever you prefer doing, for example, if I choose summarization, it will then ask me at training data. Now, this training data, uh, sorry, am I audible now? I just saw a message that I'm not audible. Can
Uh,
anyone confirm?
you are, yeah, you are.
Okay, thank you so much, Nupur. Okay, so as I was mentioning, the Studio will then ask you to add some training data. So here you can see that this training data should be in a JSON-L or a JSON format. It needs to have a maximum of 10,000. It should not have more than 10,000 samples. So anything lesser than that is good to go with. And this should be in an input output pair fashion. So let me quickly show you one JSON file that I use. So you can see I have a JSON file here. I have given some 2000 examples here. Now, what I'm trying to do here is the input that I've given is basically an article or a paragraph about some technology or something that I want the model to give a title to. So you can see the output is a title that needs to be given, and input will just be an article or a paragraph that needs a title. So this input output pairs should be given to the tuning model here. We just select that JSON file, put it as a training data here. And once you do that, you can go ahead and start tuning. In the interest of time, I will not start tuning here. But once you start tuning, it will take a couple of seconds. And then if you go back, once this tuning is complete, if you go to your prompt lab from where we were doing all our prompt engineering, you will actually be able to find your prompt tuned model as well. Let me show you where you can find it. So I did show you models that are present here. So along with these models, you will also find your tuned prompt tuned model here, which you can use for your use case ahead. So you tune it on the tuning studio and then come back to the prompt lab and then use it for your use cases. Now this is how prompt tuning works. So what the use case here is, if you give the proper set of data, it can actually give you results very near to fine tuning at a much lower cost with a very high flexibility, and you don't really need to change any model weights at all. And if you want to again retune that model, you can go ahead and again retune this. So that is about prompt tuning. Now let us jump back to our slides and look at the model strategy. So I did mention in the beginning of the session that we will see how we can choose models for our use cases. So right now what we see in the market is that everybody is excited about Gen AI. But while this excitement is there, people are also keen on understanding how to monetize this AI and how to make it more efficient. Now, it is very essential that we wisely choose the models, keeping in mind the performance, cost, and scalability aspects. Now, here are a couple of principles that would actually help you while you choose your models. The first one that you need to keep in mind is the fact that one model does not fit all use cases. That is the reason that IBM has given you a wide range of choice. You could either choose IBM specific models, you could choose the open source models, the third party models, or you could also bring your own model. And this bring your own model is a new feature that watsonx has. And people who are interested in this, just put it up in the chat. Maybe if we have, we could conduct another session on these things. Next thing that you need to also keep in mind is bigger is not always better. What I mean by that is many customers in the investigation or exploration stages, they find some wow factors in the large models and they think that, okay, that is the best fit for them. But once they move towards the production and the scalability aspect, they realize it is not as straightforward. They start hitting blockers. The bigger the model, the larger the GPU compute, the larger the costing, etc. So we should be aware of the fact that in some scenarios, specialized models are actually better and can outperform with a lower infrastructure requirement. For example, if you look at Granite, while it is trained on n number of data, it is extensively trained on financial and legal aspects. So it outperforms in BFSI use cases. And you could actually go ahead and compare if you take a large model and a Granite model and see the responses both of them give you, you will find that Granite gives you even better responses. So while it is a smaller model, it is also cost effective. So these are a couple of things that you need to keep in mind when you choose a model for your use case. Now, since I mentioned Granite, let us quickly take a look at what is Granite. So Granite is basically IBM's flagship series of large language foundation models on a decoder only transformation architecture. They are trained on trusted enterprise data across internet academics, finance, code, and legal, etc. Now, here is a glimpse of some of the Granite variants. You can also notice that some of them are open source. So in the previous week, we did have the IBM Think event where we announced that some of our Granite or flagship model, some of the variants of this flagship model will now be open source. So you can see that some of these variants are actually open source. So let us quickly take a look at each one of them to understand what exactly they do. Now, Granite 13 billion parameter model is an English large language model. It is a 13 billion parameter in size. It comes in two variants, a chat and an instruct variant. The chat variant is basically optimized for dialogue use cases and works very well with virtual agents or chat applications that you might have. So anytime that you want to deal with some customer interactions or make a customer experience more smooth, or if you have an agent or a bot that you need, in such cases where a Q&A or a dialogue or a conversation happens, in such cases the Granite chat variant comes very handy and very useful. Next, we have the instruct variant. This instruct variant is designed to perform on natural language tasks and can be customized for a specific industry via prompt tuning. We just saw how prompt tuning is done. So, using prompt tuning, you could actually make it specific to your own domain. Next, we have the Granite 20 billion multilingual model. Now, this works with English, French, Spanish, German, and Portuguese. We then have a Granite model which is specific to Japanese. It is an 8 billion parameter model and is specific to the Japanese language. We then have the Granite 7B Lab. Now, this is an open source model and is tuned using IBM's large scale alignment of chatbots or lab. Now, this is something that we'll be covering towards the end of the session, that is the Instruct Lab piece. There, I'll be covering more about this. Now, we also have a Granite code. This is present in various sizes. It's a 3 billion, 8 billion, 20, 34 billion parameters. All of these sizes are present. And this is specifically for code generation. And this family of models is trained in 116 programming languages. So anytime you want to work with code generation use cases, this is your go-to model, I would say. So go about and explore this model. Now, this is a little chart that I've prepared, which would give you an idea about the variants that we have in the Granite model series and what are the tasks that are the expertise of these models. You can see that some of the models are expert in Q&A and generation. Some of them are specific to code generation. You can see that some models can do many tasks altogether. So This would actually help you choose which model is best for your use case. You could also go about and just experiment and figure out which one fits best for your use case. Now, with that, let's see why exactly has granite actually taken so much limelight, or what is the hype around granite, and why you must go about and explore on granite. So one, uh, it is trusted. When I say trusted, Granite is actually trained on enterprise relevant content that meets the data governance, regulatory, and risk criteria that are defined by IBM AI ethics code. So you can be sure that whatever data the model is trained on is very trusted one. It is relevant content. It is all a governed content that is used to train the model. Next, it is performant. When I say performant, the improved accuracy for business domains, that especially in finance use cases and RAG use cases, Granite performs extremely well. And also the fact that it is cost effective. So if you go about looking for different models, you would see how well it is priced against the other models that do the similar task or similar use cases. Now, with that, let us take a look at what are the use cases that the enterprises currently have been looking at, or so far, whatever we have seen attraction of different enterprise solutions on what kind of use cases. Now, I've just listed six different kind of use cases that has gained a lot of limelight or a lot of attraction from different kinds of enterprises. So the first one here is RAG. While I was showing you the prompt lab demo, I've already highlighted this RAG approach. For those of you who might have missed that out, let me once just quickly refresh on that. So RAG approach is when we provide context to a model to choose the response or choose the response from that specific context, where we restrict the model and tell the model that, okay, here's the context, go ahead and give me the response only from this context. That is called a RAG approach. Now, this comes very handy when you have relevant use cases. For example, you want to create a chatbot where a Q&A feature is there. So let us take a simple use case. So if you want to build a Q&A resource where you want the chatbot to go ahead, look at the user question, and then there is a knowledge base where it needs to send that question and find the response from that knowledge base. In such cases, the RAG implementation is key. Next, we have summarization. Now, this is where you want to transform text with specific domain content into personalized overviews. For example, as we just saw that from an entire meeting transcript, we just wanted a one paragraph summary to understand what was being said in that large document. In such cases, we use the summarization part. So, summarization use cases have also gained a lot of traction. We next have content generation. That is when you want to basically generate some textual content. For example, we did see another example of generating a marketing email. So it could be some marketing campaign, or if you want to generate emails or blog posts or articles, you could again make use of Gen AI. Then you have named entity recognition. That is when you want to identify and extract some information from the unstructured text. Very essential in audit. We next have insight extraction, where you want to analyze some unstructured text content and surface some insights about it. For example, if you have a medical report or a medical diagnosis report with you, and you want the model to go ahead and give you more details about it, or an insight about what exactly is being pointed out in the medical report, what are the what are the precautions, what are the causes of it, what are the treatments of it, etc. If you want some insights from the model, it is an insight extraction thing. Then we have classification, which is very straightforward, as the name says, where you want to classify. It could be sentiment analysis, it could be vulnerability classification, etc. So these are the kind of use cases that have gained a lot of traction from different enterprises. And you could also have different kinds of other use cases, and if you have any of these use cases, you could reach back to me or the team, and we could maybe have a brainstorming session on how you could leverage that use case and leverage AI to actually help you get the best results out of it. Now, with that, we'll go to the final thing of our session today, that is Instruct Lab. Now, this is one of the latest features that have come about, and this was announced just, I guess, in the previous week or during our Think event. So, what exactly is Instruct Lab? It is a model agnostic open source AI project. The primary goal here is to enable anyone, regardless of their technical background, to contribute updates and enhancements to the existing LLMs in an accessible, manageable, and secure manner. So let's first try to understand why exactly was this even required, or what was the need. So projects are rapidly gaining attraction towards AI models. They're trying to, utilize AI models for their use cases. But while they're doing all of this, they are facing three main challenges. One, the contribution to LLM is not directly possible. So definitely when you do it, there it comes up as forks, which forces consumers to choose a best fit model that is not easily extensible. The next issue that we face is a high barrier to entry. That is, one has to actually learn how to fork, train, refine models, and then see their ideas actually go up the ladder. The third is that there's no direct community for governance, or if you want to review, curate, or distribute that fork model, there's no direct community driven approach for the same. So let's take one simple example. So if you need to prepare for your JEE exam to crack, now when you want to crack this JEE exam, you need to be good at maths, physics, chemistry, all of them. So if you hand over three different people, now there are three different people who are experts in each of these domains, and they want to contribute to a single model. One wants to contribute to maths, one wants to contribute to physics, one wants to contribute to chemistry. Now all of this can go as one enhancement to the LLM during the training process in a collaborative manner. So the Instruct Lab basically is here to improve not only the IBM models but also open source models in the ecosystem. So let's take one simple question to understand what was the analogy that I just put up. So, for example, how many of you have actually gone and explored the Hugging Face popular models? And you would have noticed that there are multiple forks that are created for these large models. Definitely, there are tens of thousands of forks created. What does this mean? This means that there are tens of thousands of different attempts of people to come and contribute back to the LLM. But since the current architecture or the current model does not allow these contributions to the model, it never really goes back to the base model itself. It stays as a fork. Now that is exactly where Instruct Lab comes into picture. So for example, if I ask a question to a model and I notice that either the response is wrong, or it is outdated, or it could have been a better answer, in such cases, I know there's something wrong on the internet there and I want to fix it. When I want to fix it, imagine if you are able to just patch fix into a model, it is a total game changer. And that is what Instruct Lab is trying to bring about. So, what Instruct Lab does is it gives a new approach to contribute to the training models that are uniquely combines the power of familiar open source contributor models with synthetic data generation, leading to a world class LLM. That is, it is a process of tuning and improvising the model by collecting skills and knowledge. So InstructLab basically builds on a new method that is innovated by IBM's research lab called large scale alignment for chatbots, or lab. Now, this is what we did see, that one of the Granite models was actually open source, and we did highlight this part there. So, what is Lab? Lab is basically designed to overcome the scalability challenge in the instruction tuning phase of the large language model training. What it does is it leverages the taxonomy guided synthetic data generation process and a multi-phase tuning framework. It significantly will reduce the reliance on the expensive human annotations that you have. So basically, what you could do with the Instruct Lab is it offers a scalable, cost effective solution for you to enhance the LLM capabilities and actually follow the behaviors without having any catastrophic forgetting. So usually when you would do a patch fix or if you retrain the model, it would go into a catastrophic forgetting. But with Instruct Lab, we would be handling all of this in a more secure format. Now, in this particular session, I'm not showing you a walkthrough or a demo of the Instruct Lab, but there are a lot of videos present both on YouTube, on Sesame, all of these where you could go ahead and check about Instruct Lab. And if you want to understand more about this, you could reach out to us and we could have a separate session on Instruct Lab because it is something that would require some time to, walk through and give you an entire demo for the same. So if you're interested, just put it up in the chat and we could take a different session on Instruct Lab for the same. Now, with this, what I will do is I will quickly show you one demo that we have built, and then we could go on the question answers. So what you see here is an intelligent marketplace that we call. So here you can see that we have an assistant. Let me quickly refresh this page. Okay, so this basic use case is when, for example, there is a user who wants to, come about to a marketplace, maybe say Amazon, and he wants to shop. But while shopping, most of us do not want to, go about tens of different products. We don't want to, go about and read the reviews. So in such cases, what we have done is we have put up a chat bot here, where a Watson X assistant bot here, which would basically help the user if he just wants to put up some questions. They could put those questions up and could know more about the product in a very simple manner. So let us quickly walk through this demo, and while we do that, I'll keep explaining you what all we see here. So first thing, say I'll ask the model, I need a mini fridge. So what this assistant does is it will go to the it will understand what section you're looking for and it will redirect you to the fridge section. So you can see all the fridges are now populated here. With this, now I can either directly go ahead and click on whatever product I'm interested in, or I could just type in saying that, okay, the first product. Once I do that, it will take me to the product description page. You can see that it talks about the product, it gives all the product specifications, etc. Along with this, you'll also see that there's a page for reviews. Now, when we say reviews, you can see that there are various types of customer reviews that we have added here. Uh, we have used our LLM or our watsonx.ai aspect here to understand or do a sentiment analysis here. So you can see we have actually segregated positive reviews and negative reviews. So it goes about and reads each kind of a review and puts it into either the positive or the negative buckets, and then it would give you an idea about how many positive and negative reviews are present. Now, along with this, we have also implemented RAG here. Now, when I say RAG, what I mean is, for example, if the user comes and asks a question like, how much is the warranty period for the compressor? Now, these kind of questions would basically be answered in a manual or the product manual that is given with this product. It will not be somewhere up front on the screen. So what this does is it goes back to the knowledge base or the product manual, finds out the answer from that, and then sends some of the passages which are relevant to our LLM. The LLM will then form a a user friendly response and give you that response here. So you can see it has actually fetched this answer from the product manual and given us, okay, 5 years is when the consumer is the warranty period, and it also gives you more details about it to understand. So you don't really have to go up and read the entire product manual. You can stay on this page and just ask those questions. Now, along with this, we have also put in questions which would, be like, what do people say about its freezer? Now, these are questions which come handy when, a customer does not really want to read through the reviews. So if there are hundreds of reviews, most of us are we don't want to go about reading each one of them. All we want is that, if there's a basic summary that could come about. So when people ask such questions, what we do is we hit the same question to the LLM. The LLM gets all of these reviews and then it summarizes them or tries to understand the sentiment of the users and gives it as a summary to the person asking this question, saying that okay, it is a good choice, it's a compact refrigerator. So whatever it finds within these reviews, it will summarize and give a very short idea to the user. So this is one of the use cases that we have built. For those of you who want to, explore more or look at different use cases, there is a site called dsce.ibm.com. I'll put this in the chat. You could also go about and look at different kinds of use cases that are built here. So this would actually help you have an idea about the different use cases.